Okay, so now we are looking at calculating Y-intercept and X-intercepts investigation. So let's do this together so we get through it and we get all the information that we need to. So we have a quadratic here, y equals x minus 3 squared minus 4. What we want to do is do the various questions, A, B, C, D, and E, for this question, and then we'll come down and we'll do number 2, and then we'll bring it together and finish off on questions 3 and 4. So, for the quadratic x minus 3 squared minus 4, please graph using transformations. So they start off by asking you, what are the transformations? So the transformations that we see here is a horizontal, shift, right, 3. And you have a vertical, shift, down, 4. Step pattern, we take a look at the A value. You'll notice that the A value is 1, meaning that it's congruent to y equals x squared. There's no stretch, there's no compression, which means it's over x. Is it up or down? Well, it's a positive in front of there, so it's going to be up x squared. Okay, so let's get a graph going over here. So my vertex is going to be 3, negative 4. So 3, negative 4 is here. Making sure I have it in the right spot. My studio audience will let me know if I've goofed up. So now we're going to move over 1 and up 1. So the 2 next points are there. We're going to move over 2 and up 4. Well, that's kind of convenient because that's going to take me right to the x-axis. And as we know from our homework and our test, that's also called the zeros. Those are 2 names for that. And then we're going to go over 3 and up 9. So that would be up to here. And that would be up to here. And I did that so quick by knowing that this is 4. So if I take 9 and subtract 4, I got to go up another 5. And so on and so on and so on. So anyway, this parabola is looking kind of pretty like that. That's a pretty good looking parabola, you know? That's a good looking parabola. State the y-intercept. Well, the y-intercept is where it crosses the y-axis, so that's going to be here. So that's going to be 5. If you wanted to give it to me as a point on the graph, you would say at the point 0, 5, meaning that you understand that the x value is 0 there. We're not leaving the y-axis. We're not going off it. And the x-intercepts, also known as zeros. Also known as zeros because, let's think about this, they are the x values that make y equals 0. So they are going to be x equals 1 and x equals 5. That's how we show them if they ask for them as zeros. If they just ask them for them as x-intercepts, you can say 1 and 5. And if they ask for the points where they cross, then it would be 1, 0 and 5, 0. Yay, that's fun. So, look what we have over here. We have the same equation, but it's asking us to expand it into standard form. Now, a couple of days ago, we talked about what standard form was. This is standard form. That is standard form. This form that we have up here is called vertex form. And it looks like this. And on a test or an exam, I can ask you for standard form, and you have to know which one it is. And I can ask you for vertex form, and you need to know which one it is. So this is vertex form. We would like to expand it into factored form. So what we're going to do is I'm going to grab a pen, and I'm going to write this out. So it's y equals x minus 3 squared minus 4. I know that that's x minus 3 minus 4, because that's what that means. That square means that the base gets multiplied so that there's 2 of them. So binomials get multiplied before the subtract 4. X times x is x squared, minus 3x minus 3x plus 9 minus 4. Simplifying, x squared negative 6x plus 5. Ladies and gentlemen, you have now put it into standard form. Now, how do I know it's a quadratic? I'm looking at a member of our studio audience. This came from their test that they were working on. Do you see that x squared up there? That's good enough to know that it's quadratic, that the highest exponent, the highest degree, that's another name for that, is 2. That makes that a quadratic. Could we do a table of values? Could we do the finite differences? We could, but it's good enough just to know by looking at it. Factor your answer from part D. Oh, exciting. So what we want to do now is we want to take this and we want to factor it. So it's a trinomial. You're going to remember from our work before that you're looking for two numbers that multiply to give 5 and add to give negative 6. So two numbers that multiply to give 5 and give 6 are 1 and 5. But remember, they have to multiply to give a positive and add to give negative 6. So they're both going to be negative, which means that this is going to factor in one step as x minus 1 and x minus 5. And you're done. There is no difference if you write x minus 5 and x minus 1. Order of multiplication doesn't matter. Now, let's check it real fast and make sure we're right. X times x is x squared. X times negative 1 is negative 1x. And negative 5x gives us negative 6x. Negative 5 times negative 1 is 5. Yay! That's it. That was a lot of fun. Did we learn anything? Maybe not. We'll save that for question 3 and 4. Question? Yes?
Did you just write it twice just to show?
Yep, just to show that you could. How be I do this? Or. Okay, pick one or the other. Okay, so number 2. We get to do the same thing over again, just in case the first time wasn't fun enough. So let's take a look at this one. And you'll notice that I have a vertex here. I have a vertex of negative 1 comma negative 9. That means that my first point is going to be negative 1, negative 9. You're going to notice that my a value is 1. So it opens up. It's asking for my transformation. Since the a value is 1, that means that there's no vertical stretch or compression. But I do have some shifts. I have a horizontal shift to the left, 1. That's why my vertex is over on this side. And I have a vertical shift down, 9. Step pattern, once again, a equals 1. So there's no stretch, no compression. So it's the same shape, and that word is congruent. It's congruent to y equals x squared, which means you go over x, and we're going to go up x squared. State the y-intercept. Well, let's state the y-intercept, but not by graphing. Let's do it by looking at the equation, because we can. We're going to find the y-intercept by setting x equals to 0. So if x is 0, if 0 plus 1 is 1, 1 squared is 1, 1 minus 9 is negative 8. The y-intercept is going to be negative 8. Find the x-intercepts. Well, for that one, you set y equal to 0. That's hard to solve for us. So we're not going to do that. We're going to use the graph to do that one. So, over 1, up 1. Hey, hey, hey! Look what just happened. I hit my y-intercept. Move over 2, up 4. 1, 2, 3, 4. Move over 3, up 9. Well, this is negative 9, so guess where? 0. And over 4, up 16. So that's negative 9. I should go up 7 more. That takes me to here. Studio audience, make sure I'm getting them in the right spot. Over 2, up 4. 1, 2, 3, 4. over 3 up 9. That's an important point because that is a x-intercept, otherwise known as a 0. And if I come across here, it should be at the same height. So I can just put that in because of the symmetry. And it's looking pretty good. And I'm going to get a nice curve like that. So looking at it, can you tell me what my x-intercepts are? My x-intercepts are -4 and 2. Now, if I was talking about them in terms of a coordinate point, it would be -4, 0, meaning the y value is 0. And it would be 2, 0, meaning the y value is 0. This one up here would be 0, -8, meaning the x value is 0. That's really important that you know that about those things. Okie dokie. Oh, just for interest's sake, because some of you have been asking me. It's in your homework, we need to know it. But if we have a line that cuts right through the parabola like that, and notice that it's cutting it so there's an equal part on either side of it, and it goes right through the vertex, what do we call that? The axis of symmetry. And it has an equation. The equation of a vertical line is going to be x equals whatever number it passes through. So it's x equals -1 in this case. And notice it's the same as the vertex value for x. Always, always, always. Okay. So, didn't ask for that. Just giving you some extra information because that's what I do. Expand. Y equals x plus 1 squared minus 9. Okily dokily, because we want to put it in standard form. So y equals bracket x plus 1 squared minus 9. X plus 1 minus 9. Multiplication before subtraction. So x squared plus 1x plus 1x plus 1 minus 9. X squared plus 2x minus 8. Life is grand. We have it in standard form. Oh, by the way, it's in standard form, which means it's in this form, right? Y equals ax squared plus bx plus c, which means a equals 1, b equals 2, and in this case, c equals -8. We understand that, right? We can pull those numbers off of there when we need them. The second part of this question is asking me to factor my answer from D. Okay, so first I got to find my answer. It's in here somewhere. Here it is. So, y equals x squared plus 2x minus 8. And I'm only factoring the right-hand side, right? The left-hand side still says y equals. We're not messing around with that. So, I'm looking for two numbers that multiply to give -8. And going to add to give 2. Because what I know, ladies and gentlemen, is that when I factor this, it's going to look like, and I got to put in the numbers there that go there. Those numbers multiply to give -8, add to give 2. So I'm thinking -4 and +2. They multiply to give -8, and they add to give doesn't work. Doesn't work. Notice I found out it doesn't work by checking. So that's no good. Let's make it +4 and -2. That multiplies to give -8 and does add to give 2. So that's going to happen to you. So +4 minus 2. Let's make sure it works. X times x is x squared. -2, 4x is 2x, -8. Life is grand. Okay, so that was a lot of fun. Did we learn anything? Probably not. So let's look at questions 3 and 4. Hopefully they're going to bring it together for us. So coming out a little bit. What connection do you notice between the y-intercept and standard form? So what I'm looking for is something about this and something about this. Any ideas? It'll be the same thing about this and this. Do you see it? The C value in standard form is the y-intercept. Okay? So standard form shows you the y-intercept really nicely. Now, the next question is, what do you notice between factored form? Did you notice I slipped a new form in here without really telling you? We have standard form, we have vertex form, and you now have a new form, factored form. It's what it looks like when it's factored. So my question to you is, what do you notice between these numbers and the factored form? So these numbers, -4 and 2, +4 and -2. Yeah? They're the opposites. Let's see if it makes sense on the one above it. See if it still works. 1 and 5, -5 and -1. They're the opposites. So what we need to say is we need to put some words to this. So what comparison do you notice between the y-intercept and standard form? Y equals ax squared plus bx plus c. The c value is the y-intercept. Bottom line. The c value is the y-intercept. I don't like this marker very much, so I'm going to get rid of it. And I dislike it enough that I'm actually going to get rid of it. What connection do you notice between the x-intercepts and the factored form? Well, the factored form, how can we say this? The x-intercepts are in the factored form, but the opposite side. Can we start by just saying opposite signs? And that's the first thing to make us remember it, right? But notice what we have here. We have the factored form x plus 4, x minus 2, and that goes to, which one do I like? I like this one. That goes to x-intercepts of -4 and +2. So if we write it like that, do we see what I'm saying about the opposite signs? We've got the +4, it's a -4 for the intercept. We got a -2, it's a +2 for the intercept. Okay, kids at home, I'm going to stop the video there, and we'll be back in a minute.